let us do another example of the work on finding modular multiplicative inverse that you may need to do when you solve a Chinese remainder theorem or any problem at all that involve modular arithmetic, like public-private cryptography, where you need to find D, which is the inverse of E. Normally, in this problem, the mode is very large, which means you cannot use inspection. You will waste a lot of time in the exam looking for the inverse by inspection if you don't know how to perform Euclid's algorithm. You have to use Euclid's algorithm. Okay, one example is you're finding 1980. You're finding the inverse of 1980 in mode 91. So how do we write this? We are looking for x, which is the inverse of 1980, and multiplying the inverse and the number, it is congruent to 1. This is the modular identity when we multiply inverse with the number. So 1980 is too large compared to the mode itself. So we better reduce this to a number which is less than 91. So what do? We get the remainder of 1980 divided by 91. We divide first and then we subtract 21. Multiply back with 91, we get 69. So it is 69x congruent to 1 in mode 91. Alright, so we get a nice number now to work on. Now we decompose this number according to Euclid's algorithm, which tells us that 91, the mode, can be written as a multiplication of 69, the number that we are looking for the inverse, with how many multiplication of what number? In this case, it is obviously a 1 because 69 is obviously more than half of 91, and the remainder is 91 subtract with 69, which is 22. Then again, Euclid's algorithm says that this mode, just like the mode before, okay, this mode, which is 69, can be decomposed into a multiplication of 22, which was the remainder before, multiplied by what? It is 69 divided by 22 multiplied by 3. But then to get the remainder, we subtract 3, multiply with 22 again, we get a 3. So we add 3. That is the remainder. Next, we keep on doing this. We shift the number to the right. Now it's 22. In terms of 3 is what? 22 divided by 3, of course, we get a 7. Then the remainder is 1. Because 3 multiplied by 7 is 21 plus 1 is 22. Now we get the 1. You see, this is the beauty of Euclid's algorithm. Normally, number of rows, the number of lines that we have to do this operation, decomposing operation, is less. A lot less than the number of time you need to multiply if you want to get the inverse by inspection. So we get a 1, then we put 7 multiplied by 3 to the right, sorry, to the left, and everything on the left we put on the right. So we have 1 on the left, which is equal to 21 minus 7 multiplied by 3. And this 3, we want to replace with 69. Remember again, we are doing modular arithmetic. The remainder and the original number are considered identical. we can replace them. So in this case, we want to replace the first number to replace here is 3. Replace is what? With 69. So it has to be a multiplication of 22 subtract 7 multiplied by 69. We replace 3 with 69. So what is the value here? We multiply 7 multiplied by 69. So the number that we want over here is 484. So that 484 subtract 483 is 1. So what is the value in the question mark here? Is 484 divided by 22, which is 22 also. Okay. Sorry. 22. Next, this is the process of reverse replacement. Next, the one that we want to replace is 22. Okay, we replace with 91. So 22, 91 multiplied by 91. Subtract with how many? 69. So 22 multiplied by 91 is 2002. We want 2001 divided by 69. We get 29. The question mark here. So we get this equation in terms of the earlier equation. Then we go back, we apply back mode 91 in the original simplified congruence. We get what? 1 congruence to 22 multiplied by 91. We will get this 0. Then we get negative 29 multiplied by 69 mode 91. So obviously in this case, x is negative 29. X is congruent to negative 29. This is in mode 91, so we have to make it positive, less than 91. 29, 29, negative, add 91, 62. Sorry, congruence to 62, mode 91. You see, if you want to do this by inspection, you have to multiply 69. Do not do that in exam. Use Euclid's algorithm. You can check if you want 69 multiplied by 62 is 4278. Divide by 91. Subtract 47. Multiply again with 91. You get a 1. Or you can check the original unmodified or unsimplified congruence 1980 multiplied by 62. You get that number. Divide by 91. Subtract 1349. Multiply 91. You get a 1 again. So the answer 62 here is correct.